We are at the beginning of a cosmological turning point. It's incredible how a simple result from James Webb has shaken up cosmology. The new high-performance telescope shows us, through a very simple observation, that our previous cosmological models must be flawed. The theory of the Big Bang and the idea of expansion as we have imagined it up to now are not complete, that much is certain. Researchers are now desperately searching for answers. What are the best new theories, and are we really any closer to unraveling the universe? The James Webb Space Telescope, or JWST for short, was built to give us unprecedented insights into the early history of the universe. With its state-of-the-art technology, the JWST enables observations far beyond the capabilities of the Hubble Space Telescope. A key feature of the JWST is its large segmented primary mirror, which has a diameter of 6.5 meters. This mirror is almost 3 times the size of the Hubble telescope and consists of 18 hexagonal segments made of beryllium and coated with an ultra-thin layer of gold. This design allows the JWST to collect much more light and thus observe fainter and more distant objects. Another technological feat of the JWST is its location in space. While Hubble is positioned in low Earth orbit, James Webb is located at the so-called second Lagrange point, about 1.5 million kilometers from Earth. This position offers astronomers several important advantages. The telescope can continuously observe cold and dark space without being disturbed by the heat and light of the Earth or the Moon. In addition, the location provides a stable thermal environment that is optimal for the sensitive infrared instruments of the JWST. James Webb is best known for its ability to observe the universe in the infrared region of the electromagnetic spectrum. This now allows researchers to see through dust clouds and study the formation of stars and planets that remain hidden in visible light. With its technologically advanced instruments, such as the near-infrared camera, the near-infrared spectrograph, and the mid-infrared instrument, the JWST can analyze the chemical composition of the atmospheres of exoplanets and search for evidence of life. James Webb can capture the light of the first galaxies that formed after the Big Bang, greatly expanding our knowledge of the origin and evolution of the universe. We can even study the physical and chemical properties of distant galaxies, stars, and planetary systems with unprecedented precision. One simple result changes everything. Believe it or not, but the new Superstar telescope hasn't even had to use its best power spectrum to shake up cosmology. For this new super telescope, it was a simple exercise that confirmed a great mystery of astrophysics. With its high-precision infrared instruments and exceptional resolution, James Webb measured the rate of expansion of the universe and came up with a shocking result. The so-called Hubble tension was not a measurement error, it is real. With this result, the scientists suddenly realized that their previous cosmology could not be correct. 100 years of astronomical work were in shambles, and to this day, there is a sense of helplessness. The Hubble tension is the discrepancy between the measured expansion rates of the universe, which is caused by 2 different methods. On the one hand, there is the local measurement, which is based on the observation of standard candles. On the other hand, there is the cosmic measurement, which is based on observations of the cosmic microwave background. Standard candles are astronomical objects with known brightness, such as Cepheid stars or Type Ia supernovae, and the cosmic microwave background is considered to be an imprint of the Big Bang. James Webb used its advanced instruments to observe Cepheids in distant galaxies with unprecedented accuracy. Cepheids are stars that pulsate at regular intervals, with the period of their brightness fluctuations directly related to their absolute brightness. By measuring the period of these stars and their apparent brightness from Earth, astronomers can calculate the distance to these stars and thus to their home galaxies. In addition to the Cepheids, the JWST observed type Ia supernovae, which also provide very reliable light and distance values. These supernovae have such a uniform luminosity that the observed values serve as pillars that allow a measurement of the universe and thus also a determination of the expansion rate. Now, the expansion rate of the universe has been calculated once again using the precise data from the James Webb telescope, and the results show the same increased expansion rate as the Hubble Space Telescope determined in the 1990s, around 73.4 kilometers per second per megaparsec. This is in contrast to the approximately 67 kilometers per second per megaparsec found by observations from the CMB and the Lambda Cold Dark Matter model. If our theories and the idea of standard candles are correct, then the measurement should be the same in both cases. Cosmic destiny is changing us. Can you imagine that cosmic destiny depends on a few measurement results? Basically, it does not. Cosmic destiny is what it is, and the cosmos probably doesn't care too much whether we measure correctly or not. How we see the world is a matter for us humans. We want to get to the bottom of the origins and mysteries of the universe because we want to understand what the universe is, who made it, and what role we ourselves play in it. Let's consider for a moment what the general worldview is at the moment. We assume that the universe has a starting point and that it will probably end at some point. Now, science so far says that there was nothing before the Big Bang and therefore somehow also that there will be nothing after the universe. This is a completely different idea from the idea that the universe could be infinite or is just one of many universes within the multiverse. The concept of the world has a direct influence on how we evaluate ourselves and our own existence. Astrophysics so far is like a jigsaw puzzle. We have many pieces that make sense and have been put together to form a somewhat coherent picture. However, the Hubble tension shows that there is something wrong with this picture. It's like a piece that just won't fit and messes up the already completed picture. James Webb showed us other things that are messing up the game. Thousands of brightly shining galaxies at a time when the universe should still be dark. These galaxies are so far developed that their time of formation must have been before the Big Bang. This is where the Hubble tension comes into play again. If our measurement methods are not correct or if we have overlooked something important, our age determinations of the entire universe may not be correct either. Then we have three possibilities: the universe is infinite in time and space after all, the Big Bang and starting point took place at a different time, or the nature of the universe is completely different from what we have seen so far. Imagine what it must have been like when people still thought the Earth was a disk, and when you get to the edge, you might plummet into nothingness. That had an impact on the mindset and psyche of the people of those eras. They were afraid to move towards the horizon because that is where the world supposedly ended. As a result, people remained more static, moving less and staying in one place for safety reasons. Today, we believe that the universe is finite. Suppose we find out that it's infinite, then our mental concept of time and space will change, and that will have an impact on our behavior as a species and our culture. Even if you are a non-scientist, you have the old cosmological ideas in you because we all learned the idea of the Big Bang and expansion in school. In Eastern traditions and religions, people believe in a multiverse in which there are many dimensions with humans, gods, demons, angels, and nature beings. Such ideas are reflected in a bizarre way in physical models such as string theory or Burckhardt-Heim's multidimensional universe. The idea of Sir Roger Penrose's cyclical universe is currently gaining momentum. According to this theory, our universe could have had a beginning, evolved, and then passed away in order to recreate itself. We also find this in some spiritual ideas that postulate a soul that goes through many incarnations. If we find the principles of eternal psyche increasingly confirmed in the scientifically describable cosmos, this will have far-reaching effects on how we judge our own fate and the meaning of our lives. Crisis in cosmology: where do we go from here? When Columbus sailed around the world and proved that it was round, some people were shocked. The church flatly refused to acknowledge the new knowledge, and some rejoiced. We have exactly the same situation today. Open-minded researchers like Michio Kaku are happy about Webb's shocking measurement results, and others don't want to admit it. The future will belong to researchers who are happy about such changes and who have a genuine interest in the truth and don't just want to be right. We already have some exciting new theories, and it's a bit like science is being redrawn. Someone or other will win a grand prize because they correctly predict the actual development or have the right instinct. Researcher Rendra Gupta has published a paper on the reassessment of the age of the universe. Roger Penrose could win a second Nobel Prize if his theory of a cyclical universe is confirmed, or quantum physicists could gain momentum. The JWST went into service 2 years ago, and it will be with us for at least another 20 years. Even the old Hubble Space Telescope is still in service and is landing incredible hits. In spring 2022, Hubble succeeded in finding the oldest single star ever sighted. This star became visible by chance and a huge gravitational lens. Webb will make further observations of the early universe, and we will see more and more details. Already, the telescope has provided further evidence of structures that could not possibly have existed in a young universe. Behind the Pandora cluster, which is a huge structure in itself, the telescope found evidence of a much older and even more gigantic structure. This shows that in the universe we consider to be young, there have already been structures so large that they go beyond our cosmological models. Webb also discovered very old and very large black holes only a few 100 million years after the supposed Big Bang. These black giants combine the mass of several million or even billions of suns. But how can this be if there couldn't have been much matter at that time? Subscribe to the channel now and look forward to many more exciting videos. Thanks for watching.